Hello, everybody. So this morning we had a really great talk on differentiable programming. And since everybody loves ML and AI, I thought we should probably look at what other research topics or what's differentiable programming and what other research topics are out there that will improve ML and AI. And for this purpose, I've invited this really illustrious panel here. Maybe we'll kick things off by maybe you can introduce yourselves and why you're here, what your connection to ML is. So on the screen, Irene, you're the one on the left, so maybe you can start off.
All right, hi everyone. I'm Irene Dea. I gave the talk this morning on differentiable programming in Kotlin. It's about the framework that we're building at Facebook. And specifically on the team, I work on the static shape checker.
Cool. Jendrik.
Yeah, I'm Jendrik. I'm CTO of Nuxit, and we're deploying a lot of machine learning into production. So I originally started in data science. Now I'm going more and more into the ops part. So you'll as well have the opportunity to join us next week for a really MLOps heavy ML track. Where we'll see each other hopefully as well.
Cool. And Alanna.
Hi, I'm Alanna. I work with Irene actually on differential programming. I'm specifically focused on the performance of our tool, so making sure we can train models quickly. And prior to that, I worked on a compiler team at a hardware startup for AI.
Oh, exciting. Maybe it's for, I don't know if people have seen the talk yet, and if that's the case, why not? But maybe, Irene, maybe you can just give a quick elevator pitch of what differentiable programming is and why it's different than other approaches.
Right. So I would say with our framework, we're trying to, so to back up, a lot of the popular frameworks out there that many of you might have heard of, JAX, TensorFlow, PieTorch, those are really great for traditional machine learning model use cases. But once you sort of step out of those boundaries, you don't really do so well in terms of performance and usability. So what we're trying to do with differentiable programming in Kotlin is we're taking a compiler-aware approach to this problem, and we're trying to support these other use cases that are outside of the traditional machine learning realm.
Cool. Alanna, what's your, you mentioned you work on performance?
Yeah, so I guess actually, it's really interesting. I won't go too into it, but so we're using Kotlin.
Give us details.
So we're using Kotlin, which runs on it. So it can compile to a number of different backends, but its primary backend is the JVM, which I guess there's other projects that have worked on machine learning on the JVM, but of course there's Spark, but machine learning on the JVM in the sense of like training ResNet is kind of not really a big thing that people do. I think a lot of people stick to Python, C++, and that stack. So the interesting stuff that I get to work on is like, okay, how do I work with garbage collection and memory management in the JVM, and how do I make that work with these C++ libraries that are especially the Intel ones, and then also CUDA that are super optimized for running things like convolutions.
So it's mainly, is it getting the data across to the native code, or is it sort of taming the garbage collector or stuff like that?
It's a combination. So for one thing, in the JVM, you can't get a big array of uninitialized data. You have to zero out that data because the JVM is like, we're memory safe. We're not going to give you uninitialized data because we're safe. And that's a really great thing about the JVM. But when you get into the performance of some of these ops, you're like, no, just give me the array. Like I don't have time to zero it, and I don't need it zeroed. So things like that.
Interesting. Yeah, all the memory safety in the JVM is sort of fighting you there, I guess.
It's good and bad. So it's something to work with, but it's something that like is obviously super useful to our users, because if users had to do the level of control that one has to deal with in C++, it just gets in the way of training the model, of doing what you're trying to do.
Right. I guess the question is, so all the training and it's mainly used for training, right? Not for inference, differentiable programming, or your Kotlin library.
I've mostly been focused on performance of training as a whole right now. I think inference is kind of what's the right way to say it? I think there are tools that are it's something to itself, and I think there are other tools that are actually pretty good at it. For example, like so training is more of like I want to iterate quickly. Like I want to make a change, and I want to see if my loss decreases. Versus if you're doing inference, you maybe have more time to just sort of like take what you've trained and feed it to an optimizer and let that run for like 5 hours before you put that in production. And so while we might be interested in that later, I haven't personally looked at that yet.
So again, Drake, I think you were not familiar with differentiable programming before. What are you using now? Do you use like Stone Age tools to build ML, or?
Yeah, I use pen and paper, and then I start differentiating. Like an iteration takes me around 10 years, depending on the batch size. So I started with TensorFlow, and then PieTorch came out, which is, I think, already 5 or 6 years ago. It's a long time ago. But that was already like a humongous jump in tech, because it gave you a lot of reusability, which I really liked, because you started having the modules, and if someone wrote a module or a neural network and you wanted to reuse it, well, you just added the class, or instantiated the class, added it to your object, and you were like, well, okay, I can just reuse the network, and it was so easy. Well, under TensorFlow, basically you started searching the index for the weights of the convolutional layer out of this humongous weight file, and you were like not really happy about doing that all the time. I really stuck with PieTorch since then. I always wanted to try TensorFlow too. I never had the time for it and never had the urge to do it, because it was just like, I really like the integration between Python and PieTorch. I definitely want to try Kotlin at one point, because it makes my life easier when arguing with my co-founder about all the cloud builds. Because Python is definitely not so efficient when it comes to resource usage. But yeah, in the end, you always have this trade-off between like time it takes me to write it in Kotlin and time to write it in Python, and then the cloud bill. And most of the time, at least in small companies, you end up with saying, well, my time is more valuable than the money I throw at the cloud provider for just giving me one more node. While I think at Facebook, that's a different story if you have the number of data scientists that Facebook has, or the number of models you try to train. But yeah, not pen and paper anymore.
So you also mentioned that you are really focusing on bringing models to production. Are you also using PieTorch for that?
Yes. So currently I still use PieTorch for that. I mean, you can get it a lot faster by just going to 16-bit floating points. And most our models are so small that is okay from the response time. I mean, given all the request catching, I mean, you get an HTTP request, and normally the time from the person asking you the question until it reaches your server is already so long that they don't really realize that your model takes 10 milliseconds more. But yeah, if you go to bigger models, I mean, you can do quantization or some other things to get it run faster, or use TensorRT, which I tried 2 years ago and never touched again because it was such a pain to build everything in C++. But and that's why I meant inference is its whole own story, because each model you can just like, I mean, you can start doing pruning, and then, well, you can make a doctor thesis out of optimizing this one model, right?
Yeah.
You have a question here. Maybe I'll just mark them off here. There's a few questions. I guess the choice of Kotlin is one question. And I think you, Irene, you answered that in your talk, that it's because of the compiler infrastructure and stuff like that. I think that's the reason, right?
Yeah. So, I mean, one big reason is also just the performance and Kotlin being a JVM language. And another big one is the compiler, the static compilation aspect, and also the static typing.
Yeah, it's interesting. I think that was also one of the big arguments for Swift for TensorFlow, the static typing in Swift compared to Python, and the static compilation rather than having to carry around the Python interpreter and stuff like that. Let's see, there's another question. I think there's a question maybe for Alanna. In regards to the ML and JVM performance, if we consider off-heap memory.
Which heap? Off of the JVM heap? Like C++?
I guess off-heap in the sense of not on the object heap, not a Java object, but like use, I guess, unsafe or something like that to allocate a big buffer.
That, yes, I haven't. That has been on the to-do list actually for a little while.
Oh, okay.
That's what's happening for the prototype GPU support that I have right now. You know, the memory has to live on the GPU, so we are doing that. But yeah, also like I'm guessing what is meant is wrapping in float buffers to expose to Java. I haven't tried that. That is another thing to try.
Mm-hmm. Maybe you can actually, talking about the GPUs, what's the story with hardware? If you write your code in Kotlin, how much can you offload to fancy pants hardware?
Well, so it depends on the software libraries available for the hardware. So, I mean, GPU, like basically anything we can connect to from C++, we can sort of send down through Kotlin. The challenge becomes when, so with cuDNN and CUDA on GPUs, it's relatively straightforward because you can run sort of an op at a time on the GPU. The part where it gets challenging is the world of accelerators, where if accelerators sort of aren't expecting the same op set, or if the cost to offload to the accelerator is high, then you're going to need to send down a group of operations at once, and that's sort of that's something that we hopefully plan to support in the future. We'll see. I would like to support that in the future. Can't speak for everybody, but so yeah, we'll have to see how that goes.
Interesting. I literally had a question. Oh, go ahead.
I actually have one. Is the Kotlin implementation actually already Onyx compliant? Because it's like I think 2 or 3 years ago Onyx started, and it was like, well, okay, we can finally start moving our AI models from A to B to C, and nobody had to worry. And then it just disappeared, and nobody ever talked again about it.
Yeah. I think at one point I played with Onyx, but I'm not sure what. Yeah, I haven't seen much activity around it recently. Yeah. So
Okay, it's nice that others have the same experience, because it was like that's how I felt as well.
Yeah, no,
I think
the Onyx stuff was really big when we were doing a lot of exploratory stuff with our project, and then same experience where it just kind of disappeared, and I think and people were, I don't know, no one talked about it ever again.
So Onyx is the sort of interchange standard for models, I think, is it? Or
yeah, it's an
tried
IR.
to be.
Yeah, it tried to be an IR for models so that you could, take something in TensorFlow and then like have it, spit out something in PieTorch or something like that.
Mm-hmm. Mm-hmm.
Or TensorRT.
You're gonna get in such trouble, Jendrik.
Sorry.
Actually, talking about native code or JVM, so currently Kotlin also has native compilation support. Do you run on all of those, or is it just the JVM?
So right now we are I think we're focusing mostly on the JVM. It's true that Kotlin can also target JavaScript and native, which is great, because that means they can really be heavily supported on both mobile platforms and also web programming. But currently, I think the main use case of Kotlin Native is really to have the different types of mobile support. So I don't think the purpose of Kotlin Native is necessarily for performance at the moment, and we haven't really looked into that.
Yeah, I guess it's iOS and stuff like that you need to natively compile it. Actually, how does Kotlin work on Android? Because I guess it's compiled to Dalvik, or okay.
Yeah. Just similar. Yeah. So it uses the JVM backend to be used on Android.
Mm. Another question came in: Kotlin pros and cons. I think we just talked about different backends and stuff like that. I see knowing smiles. I feel that's a story. Who wants to?
I actually
Alanna.
love using Kotlin.
Yeah, I mean, Alanna, go for it. Talk about your passion for Kotlin.
I came from the Python C++ world, and I was a big fan of both. I was afraid of JVM. But the experience of writing Kotlin is very nice in my opinion, and I like having the type system, but it's not a particularly restrictive type system, in the sense of like it has, you don't have to declare a type on a variable. You just have to declare it on a function, which Python is getting towards too with its type hints. So I think, I don't know, it's personally a really awesome experience. I like it. I think Python can be faster for sort of quick stuff for me when I don't care about, when I can keep in my mind all of the argument and return types to all the functions in my code, then like Python is perfect, and I think it is faster for me. But the documentation that I get from the types, and especially from the tensor typing that Irene has prototyped, I'm her biggest fan of that. It's a pretty awesome experience, in my opinion. Someone else can speak to it.
I can give some cons, but I mean, we're very heavy on the Python stack. I mean, one reason is, of course, the ecosystem for ML AI is simply so humongous in Python. And we indeed use all the type hints in Python, and I totally agree that if possible, use that, because I think it's nicer when they're first-class citizen, but it makes it easier for people to get into a language if you don't have to start with typing and then later explain them, by the way, there is a thing you can use to basically check a lot of things which will otherwise lead to bugs. I actually did, like, I went from Python to Java to Python, and not to Kotlin yet, because I just stuck in the Python world. Because I'm always thinking, well, I have Docker, what do I need a JVM for? It's like, it's all virtual anyhow. But I mean, that's maybe very particular to us developing our services. And I mean, we use lots of Golang for microservices as well, Paula. We see your comments. Because it's simply super fast for small microservices. But for everything that's ML/AI related, we're basically we're faster in developing Python, and that's basically all our pro for using Python. And I think if you're used to writing Kotlin and someone has an amazing Kotlin library for ML, definitely go for that. I mean, in the beginning, go with whatever is most comfortable for you to start with, right?
Yeah, definitely. I would really say, though, that as someone who's come from also like a lot of Python, I do think Kotlin is actually like a great starting language, and I wouldn't even say that it's much heavier than Python. It's definitely much lighter than Java, and I think it's the way that like there's an interpreter as well, so you can script stuff pretty quickly, and I can't. Well, Python without types, I cannot handle anymore. Like when I use Python code without types, I have no idea what's going on. And to that point, also, like when I look at model code in Python that doesn't have any comments about the shapes, and that drives me nuts. Like I have no idea what's going on. If you go on Stack Overflow, which I've done many times, and look up something like, tensor shape mismatch, like you will see so many errors from people who are just trying to use like the like basic tutorial, like com2D, like just a few layers, like thing on like a new data set. And they just have like all these issues because they're using it on a new data set, and maybe 2 of their dimensions are like flipped, and that's it. But they run into all these issues and they have no idea what's going on. So I feel like from that perspective, that's where like types and like static shape checking are really beneficial. And then also I think as people are like writing bigger ML programs, I feel like doing little scripty stuff in Python is great, but when people are writing bigger things, I think that's where, having a statically typed language with static shape information and great IDE support is going to be really crucial, especially like when you're collaborating with people and you're like sharing code. I think that's where it gets really important.
I totally forgot about the IDE. Yeah, I want to jump on that. So Kotlin comes from JetBrains. Probably people know this already, but JetBrains makes IDEs. So Kotlin is designed to be awesome in the IDE, and it is. It's like when you start writing code in Kotlin, in IntelliJ, it gives you all these suggestions. It tells you how to write canonical code. I came from like a world of Python with not that many suggestions, and you just sort of learn. You learn your PEP8, you learn your rules, and it's actually really nice to sort of have that be taught as you're learning what to do there. And also, if I can, no, go ahead.
No, I was just going to add to the IDE point. I think also because the IDE is also hackable, like you can also add suggestions that have to do with, are more domain specific. So we, have IDE support for like static shape checking, and we can add IDE support for other things as well.
So Jendrik, you look increasingly jealous.
No, I mean, I have VS Code set up with auto formatting using the black formatter, have MyPy type checking, and automatic make 8 testing. So I'm super fine with staying with Python, especially since, I mean, the advantage of VS Code, what I prefer over the JetBrains one, is that you can have multiple languages in one IDE. which is, I mean, there's always this fight. If you're a person writing one language, you prefer you just have one language. But if you write Go, Python, Helm charts, then Terraform code, you're just like, I just want all of that in my IDE and don't bother me. And if it loads for 10 seconds, that's fine, but then it works. But yeah, if you're focused on the one language, I totally agree. There's nothing nicer than a nicely set up IDE. Then you don't have to share your settings file with half your company, which is what I'm currently doing. Actually, I had one question regarding the static shape checking. How does it handle if you have, I mean, especially for semantic segmentation, you can somewhat reuse the network for different image sizes. Does that currently work, or is it very static?
Yeah, so
Generics.
Yeah, so
yeah.
we have polymorphism, or we do support polymorphism with shapes. So you can have so you could say maybe your inputs is n and your outputs is m, and then n and m get assigned at the call site when you actually use it.
Oh, neat. Okay.
Just because it keeps coming up. Go for ML. Jendrik, you mentioned, do you use Go for actual ML workloads or for other stuff?
No, we use it for microservices, especially for stuff that needs to get super small. I mean, the memory footprint of Go is amazing. Especially if you run in the cloud, you can just put 100 Docker or 100 Go containers on one node, while having 2 Python nodes just explodes it. But we don't use it for ML. Yeah, I mean, simply because the Python ecosystem is there, and I think in Go you would need to rebuild a lot of it. And yeah, I mean, that's why we simply use Python. And I mean, that's, I think, generally one of those advantages of microservices. It's like, I will definitely try the Kotlin ML stuff at one point, and I'll be like, well, okay, I just put it alongside the Python stuff and alongside the Go microservices. So yeah, I'm generally interested to see how many languages will support ML, because it makes sense if you have monolithic applications where you basically have to stay in your language. But I mean, with Kotlin, you can basically integrate C++. With Python, you can integrate everything. The question is just how long it takes to call during runtime. So yeah, it'll just be interested to see how many different languages will support it, and actually where Onyx goes, because I think it was a great idea to basically, if we have all the frameworks, we basically want to move models from A to B to C. It's like this cross-language support will be, I think, very, very interesting as well. But we're not using Go for ML currently, at least. Let's see what comes in the future.
Cool. Alanna,
also, regarding your comment about Onyx, it'll be also interesting to see how models will evolve. So a model that we've sort of talked about on our end, which we think is pretty cool, or I think is pretty cool, I guess, is the slide model, which uses hash tables and a smart hashing scheme to drastically sparsify a densely connected network. And I don't think Onyx is going to be able to rip that anytime soon, or maybe it will. But it seems like ML research, like there's a direction of ML research that's just sort of like exploding in the kinds of things you can do with architectures. So it'll be really interesting to see what happens there. And I guess that's sort of what differentiable programming is excited about. But
another question I wanted to ask. Actually, it's a good point. So with Onyx, you mentioned that there's things you can't really represent in Onyx. So does the interchange model even make sense, or would it have to wait for another iteration of research to know what it have to support?
I think generally it's a question how much. I mean, I think it's simply not so needed by the community right now, because basically I think you need to convert every layer in every language to the respective layer in every other language. and that's, I think, simply a humongous amount of effort. But I mean, that's what is limiting it. I think for dense layers, it has no problems. Convolutions are no problems. But if you start doing, I mean, the first thing is already, I think, striding is like, where do you start counting the stride is different between TensorFlow and PieTorch. They start shoveling around the dimensions. So what was the direction? I think PieTorch prefers batch second when it comes to time series, while TensorFlow likes batch first. Which makes sense, because I think PieTorch is more tailored to CUDA, which likes it batch second. I don't know. It's like it. I mean, that's where shape checking actually helps you, because then you know which dimensions you run around with. To come back to that topic, but I think it's simply it's not that needed yet, but I mean, especially if we see models appearing in more, like, especially new research papers appearing in other languages than Python, it will get really relevant, because then if you basically want to reproduce the paper, you somewhat need a way to transport the model around, right? And especially if you want to then start iterating on it. So I hope it will reappear, but it's a humongous effort, I think. So that's why it probably died down a bit, because then people realized how complex it will be.
Cool. I think there's one question. I'm not sure if we can have an answer. Wondering if Kotlin is fit for web application or ML or mobile, all of these. I guess it's always, as you mentioned, it's for Android, so I guess people are using it there. Web application, I don't know if Kotlin for JavaScript, that's mature enough or not. Any comments from you?
I've tried it, actually. It's pretty good. I mean, I haven't tried it for ML specifically, but you know, JavaScript or Kotlin for JavaScript is actually quite easy to use. And I originally wrote this program, maybe like 700 lines in Kotlin for JVM, and just flipped the switch for JavaScript, wrote like a little thing to actually display stuff on web, and it worked. Like, I didn't have to change any of the meat of the code. So it's pretty good. In terms of speed, I'm not sure if it was like very performant. So, but yeah, I mean, I think it's great that I was able to use the same code, and I think that's one of their main goals, is code reuse for having these different backends.
Cool. So we have 7 minutes left. So just before we started the panel, I threw out the word probabilistic programming because we all like to introduce new paradigms. Who would like to do an elevator pitch or elevator explanation for probabilistic programming?
I can kind of explain it. Again, I'm not a probabilistic programming expert, but this is my attempt. But probabilistic programming basically aims to allow people to add a level of uncertainty to their models and to show uncertain statistical relationships. So, for example, what you do with probabilistic programming is you generally first give some assumption about your world in the form of, you might have like some distributions, and then you provide a set of observations. So you have, this is how I think the world functions, and then you have, this is what I see happening in this world. And then what comes out of it is a prediction of how your world actually is given those assumptions and your observations. So that's my high level overview, and it's a great way to add uncertainty, because I mean the world is just full of uncertainty, right? And you have these underlying relationships, these underlying effects and causes to the data that you actually see. So that's why it's important.
So is this in the ML space, is this an alternative to sort of the various networks and models, or is it in addition to those?
I think it's kind of like separate. I feel like it's an added. It's like an added information to your models.
Mm-hmm.
Yeah, because it requires that. Oh, go ahead.
No, go ahead after you.
I was just going to say, because it requires the addition of the assumptions, and like if you're just working on your machine learning model, then you just have your data and you're just going to throw it at which architecture you've picked or a couple of them, versus the like programming in the assumptions is kind of a big input, because you're sort of in a way you're sort of restricting the model. This is my understanding. This might be a little off, but you're sort of restricting the model in a way based on what you think the world looks like.
Yeah, I mean, I think where you can actually add it together is basically when you make probabilistic predictions. So we, for example, used that when we did power predictions. When I worked at a company, we basically wanted to predict how much power we consume to basically then go to the stock market and buy the amount we need. What you want to know is not only the answer, it's like you will use 50 megawatts, but you want to know, is it like, well, is it within plus and minus 10 megawatts, or are you uncertain from 100 to 0? Because that's the strongest difference to what you will actually buy. And the nice thing you can then as well see is if your input data goes out of the training distribution, you can basically as well see how your outputs increases in uncertainty. We actually modeled that with power outages we had. So basically you could see in advance that some sensor data went crazy, and then you could just see that the model got more and more uncertain how much power we will actually use. And it's helpful for that. It's basically nice to know in advance or how certain your model is itself about the prediction it does. So for that, it's pretty handy, I think.
Cool.
So we have we have a quick question about hang on, where am I? Oh no, that's it. Using Rust, I think, for inference, does the language in that sense make that much of a difference for inference?
I mean, different languages make a difference for inference. I think basically all models developed in Python-based frameworks are exported to C++ for inference. So certainly potential for a difference there. I'm not sure how big the difference would be, but certainly potential.
It is reasonably big. So at least going from Python to C++ accelerates stuff, but normally the first things you do is going to float 16 or quantize your model, because going from float 32 to integer 8 stuff actually gives you like at least a 4-time increase, maybe even more depending on how optimized your hardware is. So at least for me, that was like the gain I needed, and then I didn't bother writing it in Rust, but kept it in C++. But probably you can go even faster. That depends a bit on how good your compiler is as well for the language, I assume. I'm not really a compiler person, but I think there are differences in how well they optimize. So
I'm being told by the monitors that we are basically out of time. That was a really excellent discussion. I think everybody here has some homework to do. Not you folks, but the audience. Lots of stuff to look. And thank you, Irene, Jendrik, and Alanna.